Let's take a look at this program in C that illustrates bitwise manipulation. So we're going to start off with this binary value here in variable A, and it's going to be our original number. B is going to have a mask value. Then what we're going to do is we're going to take these two numbers and bitwise AND, OR, and exclusive OR, and then show the results here in hex. And that's what this program does. Now you can see at the bottom here A is B6, 1011 is B, 0110 is 6. Variable B is 1101, which is D, 1011, which is B, and that works. So let's see what it's got here for the result of bitwise ANDing of these two values. And we see it's 92, bitwise ORing is FF, and bitwise exclusive ORing is 6D. Let's take a look and see how it came up first of all with the bitwise ANDing as a value of 92. So when we take a look here with the AND function, the only way you can get a 1 in the result is to have both bits 1. So these are both 1, these are both 1, these are both 1, so all the other bits will be 0. So in this case we get 1001, 0010, which is indeed 92. Now what we want to see is how did it get a bitwise value of FF for ORing bitwise, and how did we get 6D for exclusive ORing. So let's see how that happened. So if we take a look here for the OR function, the only way you can get a 0 is if both inputs are 0. In the case we've got here, there's no case here where both inputs are 0. That's why indeed we get FF. Now 6D, let's see how it came up with that. And the way exclusive OR works is this. If both bits are the same, the result is 0. If the bits are different, the result is 1. So if you have two 1s or two 0s, the answer is 0 because the bits are the same. So I like to think of this as women going to a fancy dress ball. Two women show up with the same red dress, fashion disaster 0. But if one shows up with a green dress, one with a red dress, fashion success, or vice versa, fashion success. So to be exclusive, you got to be different. That's how you stand out. Now let's take a look at a summary of how these functions work in terms of bits. If x is a bit in the original number and we try and mask that with a 0, our result is always going to be 0, or it's always going to clear the bit. Why is that? Well, let's take a look. If this is 0 ANDed with 0 is 0, 1 ANDed with 0 is 0, so it doesn't matter what the value of x is, you're always going to get 0, so it will effectively clear the bit if the mask bit is 0 for AND. However, if the mask bit for AND is a 1, then whatever the original bit was, that's what you're going to get as an unchanged bit coming out as a result. So if this is a 0 ANDed with 1, that's a 0, a 1 ANDed with 1, that's a 1. So the bit will come through completely unchanged. In terms of an OR, if you bitwise OR it with 0, you get back the original digit. 0 ORed with 0 is 0, 1 ORed with 0 is 1. But when you take a look at bitwise ORing any bit with a 1, you're always going to get a 1 regardless of the original bit. So if this is 0, you get a 1. If this is 1, you get a 1. For exclusive OR, as we said, it has to be different. So if this is a 0, that's going to be a 0. If this is a 1, that's going to be a 1. So no change if you exclusive OR with a 0. However, if you exclusive OR with a 1, a 0 exclusive OR with a 1 is a 1, a 1 exclusive OR with a 1 is a 0, so it completely inverts the bit. Let's take a look at an original number of AA and a mask value of F0 for all these three functions. So if you take a look, we have our original number in blue, and the 1010, part of it gets through completely unchanged because we are ANDing with 1s where the bits get completely unchanged by this function. However, if you take a look at 1010, if you AND it with 0s, those bits are masked out or zeroed by this function. If you take a look here, here's original number in blue. These digits here make it through because these are 0s. So these digits come through completely unchanged, but all of these digits are now set to 1 by the OR function. If we take a look at exclusive OR, anytime you have 0s here, these bits here will come through completely unchanged, Whereas these bits this time will be completely inverted, so 1010 will become 0101. And I'm hoping you understand a little better now how bitwise AND, OR, and exclusive OR work.